Okay, in this video, we are again trying to find the area bounded by a couple of curves. So let's find the area of the region bounded by the curves y equals sine x, which is going to be the red graph, y equals the sine of x. Y equals cosine x, which would be this blue graph. And then the lines x equals 0, the orange line, and the line x equals pi over 2. So I graph all those lines. And by the way, if you're graphing x equals pi over 2, this is just a vertical line at pi over 2, and pi over 2 would be around 1.6. So as you can see, that's where I've got this graphed. So find the area bounded by all those things. And that is going to be this area right here, and also this area right here. Okay, it is not the area below, and the reason it's not the area below these two regions is because it doesn't say anything about, and also the line y equals 0, right? So it's not bounded by y equals 0, which would be the x-axis. It's bounded by these two lines, vertical lines, and the two curves. So this one might be a case where it might take you a little bit of time to figure that out, but it is not this region down here. It's just those two regions. Okay, so from the last video when we just said that we needed to find, the integral from, in this case would be 0 to pi over 2 of the top function minus the bottom function. Well, the problem here is that the functions cross, and the function that is on top, which is cosine x, later on becomes the function on bottom. So in this video I'm going to talk about how you handle that if you have your entire region broken into a couple of different sections where the top function is defined differently for each one of those. So the way you're going to do that is we need to figure out where this intersection point is at, so I can split my integral up into essentially just this first area and then also this second area and add those two things together. So what I would want to do is I want to take my two functions that do cross, which would be sine x and cosine x, and I want to say when do those things equal. And I'm specifically looking, in the case of a trig function, I know these things are going to cross a lot, but I want to look over the region from 0 to pi over 2. So I'm talking about when do these things cross between 0 and pi over 2. And so I would go, go about solving this. I could do it algebraically, or I could solve this just really thinking about what it's asking and using the unit circle. So I'm just trying to figure out when does sine x equal cosine x between 0 and pi over 2. So if I'm thinking about the unit circle, 0 to pi over 2 is just this first quadrant 1, this first region here, and when is my sine value equal to my cosine value there? That happens at pi over 4. Okay. Now, a way I could solve this algebraically is I could maybe divide, let's say divide both sides by cosine, and then I would get when does tangent x equal 1. Okay, if I divide both sides by cosine, and I could solve that, where is tangent 1? That happens at pi over 4. So either solving algebraically or just thinking about the unit circle and what it's asking, I know that this x value where they cross is pi over 4. So what does that do? That allows me to separate my integral into the integral from 0 to pi over 4, where the top function would be cosine x, the bottom function would be sine x. So that's this region right here. And then I'm going to add to that the integral from pi over 4 to pi over 2, that would be this region right here, of sine x being on top now, sine x minus cosine x dx. Okay, so now I'm just going to evaluate each one of these separately and just kind of add the answers together. There is one other way to handle this. It's actually a little bit easier than doing that. So One thing I could do is, evaluate this, plug all that in, evaluate this, plug all that in, which is totally fine. But what you should notice if you look at this region is that this region is exactly the same area as this. Right? They are exactly the same. So instead of doing this, I could actually just do 2 times the integral, and I could just pick one. I'm just going to do the first one. 0 to pi over 4 of cosine x minus sine x dx. Now that's not always going to be the case whenever you have to split this up. I need to be clear on that. So if I have to split it up into 2 separate integrals, it's not always going to be the case where the areas are exactly the same on both sides of that intersection point. But in this case it is, and it's going to make it a little bit easier when I go to do this, and I only have to evaluate one integral instead of 2. So antiderivative of cosine would be sine, and the antiderivative of negative sine is going to be positive cosine, because the derivative of cosine is negative sine. And so I then evaluate this from 0 to pi over 4, and I'm going to multiply my answer by 2. So it's going to give me 2 times the sine of pi over 4 plus the cosine of pi over 4 minus the sine of 0 plus the cosine of 0. Let's see, sine of pi over 4 is going to be the square root of 2 over 2 plus the cosine of pi over 4, which is also the square root of 2 over 2, minus sine of 0 is 0, and the cosine of 0 is 1, so it's going to be minus 1. So we have 2 times, if I add these two things together, you have root 2 over 2 plus root 2 over 2. That's just going to be root 2. Right? That's, think about it as a half of root 2 plus another half of root 2, which would just give me root 2, minus 1. And then I'm just going to distribute that 2, and I'm going to get 2 root 2 minus 2. And I will say that that's good enough for my final answer. Okay, so it's a little bit easier to work it out that way instead of doing both of these. But if I did both of these, each one would give me the answer of root 2 minus 1, and then I would just, adding those together, get this same answer. So a couple things in that. One, make sure that if they intersect, you figure out that intersection point and you separate your integral into 2 separate ones. And secondly, if you ever have symmetry going on here and you've got a couple of the exact same areas, you only need to figure out one of them and then multiply that by 2.